Upstate Medical University in Syracuse, New York invites you to be the informed patient with the podcast that features experts from Central New York's only academic medical center. I'm your host, Amber Smith. Gene-edited pig kidneys have been transplanted into human patients a few times, and some doctors are hopeful this could be a way to address the shortage of donor organs for people. I'm talking about this with Syd Johnson. She's a professor of bioethics and humanities at Upstate. Welcome back to The Informed Patient, Dr. Johnson.
Thank you.
Animal to human transplants are called xenotransplants. Are they legal in the United States?
They are not currently approved by the FDA for therapeutic use. There have been some experiments using organs from genetically modified pigs since 2022, and that was using the FDA's expanded access or compassionate use exemption program. The biotech companies that have developed the pigs were given approval earlier this year to start clinical trials of kidney xenotransplants in humans. So we are still in the experimental phase.
And how many pig kidneys have been transplanted into humans, and what have the outcomes been so far?
So the first two xenotransplants using organs from genetically modified pigs were heart transplants, and that was in 2022. Both of those recipients died within a few weeks. 4 pig kidneys have been transplanted into living humans in the US. Before that, there were some experiments with transplanting into brain-dead humans. The first pig kidney recipient died a little less than 2 months after his transplant. The second received both a pig kidney and an LVAD, a heart device, but that kidney was removed after 47 days, and that patient also later died. The third recipient recently had her kidney removed because it was showing signs of rejection. She had that kidney for a little less than 4 months. And the fourth patient had a pig kidney since January, and there has been no further news about him.
Now, these are, like you said, compassionate use, so these are pretty sick patients.
The first 2 heart transplant patients were very sick and had no other options for a human heart transplant. The first human to receive a pig kidney was also quite sick, had already had a human organ transplant, which failed some years ago, and was also having difficulty with dialysis. So this was also a sort of last chance and only option available for him. So the hope of the clinical trials is that they will be able to enroll patients who are not quite so sick so they can separate other things that might be complicating their care or resulting in their death.
Now, aren't some heart valves made from pig kidneys that are already in use to replace damaged heart valves in humans now?
There are a few types of heart valves. There are mechanical valves, there are human valves, which come from organ donors, and then valves that come from animals, and those include pigs, horses, and cows. And those animal valves are decellularized, so they don't pose the same risk of rejection that transplanted organs do. They do work, but a heart valve is very different and much simpler than an organ. Organs have much more complex functions.
Why are scientists using pig organs rather than, we think of monkeys or chimpanzees being more similar to humans, but why are they using pigs instead?
So in 1999, the US FDA and the Public Health Service effectively banned the use of organs from non-human primates because of the enhanced risk of xenozoonosis, the transmission of disease-causing pathogens. Because humans and non-human primates are such close evolutionary and genetic relatives, it seems like their organs would work better, but there's also greater risk that viruses from those non-human primates could be transmitted to humans through the organ transplants. The earliest attempted xenotransplants back in the 1960s and the 1980s did use organs from chimpanzees and monkeys. But with the development of CRISPR, the gene editing tool, efforts to genetically modify pigs so that their organs could be used instead really began in earnest. Pigs are separated from humans by about 80 million years of evolution, but they are also mammals and they are roughly the right size to have organs that would be suitable for humans. And additionally, they grow fast and they reproduce quickly. Those things make it favorable to try to get a pig to grow an organ for a human. But the question remains whether humans can outsmart evolution and engineer a pig that would actually grow organs for humans.
Can you talk about the risks of putting genetically modified pig organs into humans?
Well, one risk is the risk of zoonosis. It remains there with pig organs because pigs have endogenous viruses that we know can infect human cells in vitro. And they've also been transmitted to monkeys in the transplant experiments that have been done. One of the targets of the genetic modifications is to try to eliminate or neutralize those pig viruses, but it's unclear that they've really succeeded there. The first human recipient of a pig heart, in that patient, they found that the heart was infected with porcine cytomegalovirus, which was supposed to have been eliminated in the genetic modification of that pig. And that may have contributed to the patient's death. And of course, that's only the viruses we know about. There may be other viruses that pigs harbor, which we do not know about yet. The really big issue with zoonotic disease is that there is the potential that a pathogen could infect an organ recipient and then spread to other people. And in a worst case scenario, something like that could spark another pandemic, like we saw with COVID. Transplant patients are immunosuppressed, so they could harbor viruses for a long time, and that would give those viruses many opportunities to mutate into something that could spread to other people.
I know with transplants, one of the concerns is that the recipient, their body will reject the organ. Would they be more likely to reject an organ from a pig than from another human?
They are. With allografts or human to human transplants, the organ donor and the recipient are matched, and we look at factors like their blood type and antigens that might reduce the risk of rejection. In addition, the recipient takes immunosuppressing drugs, which are to help fight off rejection. With pig organs, although the pigs have been genetically modified in part to remove some of those antigens that might lead to rejection, it's still an organ from another animal. It's not matched to the human recipient, and the immune system will identify it as foreign and try to attack it. So the immediate risk there is hyperacute rejection, which can be very quickly fatal. In all of the early experiments back in the 1960s, that's what killed the patients, often within a couple of hours. They've managed with the genetic modifications and new immunosuppressive therapies to avoid hyperacute rejection with pig organs. But of course, those organs are still experimental, and the drug regimen that they're using to fight rejection is also experimental. Some of the drugs that they use can also damage and compromise the organ itself. And in some of the recipients of pig kidneys, there have been episodes of rejection, and that includes the first and the third recipient.
How long are these organs meant to last once they're transplanted?
So there's a couple of goals that have been expressed for xenotransplant. And the most often cited goal is to end the organ shortage and have organs on demand for anyone who needs one. So we're talking there about a permanent organ, just as we would be talking about a human organ transplant. If that was achievable, it could potentially save lives of many people who are waiting for organ transplants. So far, however, no one has survived more than a few months with a xenotransplanted organ. So some clinicians and some researchers talk about using those organs not as the end goal, but as a bridge to transplant with a human organ, something that will keep a patient in organ failure alive long enough to get them to a transplant with a human organ. Those two goals, though, are clearly not compatible. using xeno organs as a bridge really just kicks the problem down the road for a few months or for a few years. And then what, right? We will still have an organ shortage in a few months or in a few years. But there we've also exposed that patient to the risks of xenotransplant in addition to all of the other risks that they might be facing. So those are a couple of the goals I think that have been expressed. I think the most optimistic people think that this will simply eliminate the organ shortage.
This is Upstate's The Informed Patient podcast. I'm your host, Amber Smith. I'm talking with Upstate bioethicist Syd Johnson about the use of gene-edited pig kidneys for transplant into humans. Let's talk about the ethics of this. Are there concerns about the pig's welfare?
The pigs that are being kept here are kept in indoor, sterile environments that is designed to prevent them from acquiring pathogens. The modifications that are used result in piglets who are cloned, who are born by C-section, who are taken from their mothers immediately after birth. Those are pigs who never see the sun and never get to touch grass and don't get to wallow in the mud, which pigs genuinely like to do. And in addition to that, pigs are really social, intelligent creatures. They're often described as being comparable to dogs in their intelligence and their sociality. Nothing about the way that they're raised allows them to engage in their natural behaviors. So when you see reporting about the conditions in which the pigs are raised, it often talks about how pampered they are, how they get clean food and purified air and water. I mean, that's really PR for the biotech companies because none of that is done for the benefit of the pigs. It's done to prevent infection. And then they'll be killed at several months of age. So I don't think that's a good life for a pig. And so there are genuine concerns about pig welfare in this case. And anytime you do experimental genetic modifications on animals, there can be unintended and off-target effects, including some that can be fatal or can seriously compromise the welfare of that animal. So how many piglets died to get to the tweaks that are being used now? What are the effects of those genetic modifications themselves on animal welfare and on animal lifespan? And what are the effects on the lifespan of the organ once it's transplanted?
What concerns are there regarding the patient who needs a kidney?
Kidneys are the organ that is most needed, and the majority of people on organ transplant waiting lists are waiting for a kidney. Now, we do have an alternative to kidney transplant, which is dialysis. Dialysis is difficult. It's very time consuming, and it can result in really poor quality of life for patients who are undergoing dialysis. We know that they do better when they're able to get a kidney transplant. But one question to ask here is, would they be better off with a non-human kidney? Would that be better for them than continuing with dialysis? And are the benefits worth the risk? So far, no one has survived a xenotransplant. So it's unclear whether or not the benefits of a few extra months are actually worth the risk.
Getting back to the pigs, I'm thinking about this. Many pigs in America are raised for food. Is that ethical?
So I think a lot of people are comfortable with the fact that pigs are raised and are killed for food, but at the same time may not be comfortable with how we do that, with the conditions in which pigs are raised and with the way they are killed. I think many people would like us to be as humane as possible in the way that we treat animals, even if ultimately we are going to kill them and use them for food. The notion that millions of pigs are killed every year for food has been used by some to say, and therefore it's perfectly okay for us to use pigs in this other way, which will also result in their death, but we're going to take very good care of them and keep them under good conditions and so on. I disagree that the conditions are actually the right conditions for a pig to live a good life, but I also think that these are very different animals. These are animals that humans have created. by modifying them. There's nothing like one of these pigs that exists in nature, and there's nothing like one of these pigs that nature would have ever created, right? And so I think there are legitimate questions there about whether we can justify the way that we are using these animals.
Scientists for years have been trying to make this animal to human transplant work because of a legitimate shortage of human organs for transplants. Do you see this as a potentially good way of solving the problem of the shortage, or are there other better ways to do that?
Experiments with xenotransplantation have been going on for more than 60 years and have not succeeded so far, have not succeeded in saving a human life. I don't think this is the right strategy for us to focus so much money and attention on, and I remain skeptical that it's ever going to work. But let's suppose, hypothetically, that it does work someday and that patients can survive a xenograft for a reasonable period of time. The pigs are being developed and are owned by a couple of biotech companies who have invested billions in the development of these pigs. Those same companies have paid for the experiments that are being done and are paying for the clinical trials that will occur in the near future. So in this hypothetical future where xenotransplantation is possible, we're going to have organs that are owned, they're sold by biotech companies in this organ marketplace. How much will they cost? How will we ensure that access to life-saving organs is fair and equitable and just? Or will they just go to whoever can afford to buy them? Our current system of donation is not perfect, and we have this severe shortage. So justice and fair access remain challenging. But I think an organ marketplace would change that equation very much. And I have concerns that we wouldn't be able to maintain anything like equitable access to organ transplants. And there are other ways of approaching the shortage of organs. First, we could do better at preventing organ failure in the first place by better controlling chronic diseases like hypertension, diabetes, hepatitis that can lead to organ failure. We have treatments for those illnesses. Second, there are efforts being made to develop better treatments for organs that are failing to regenerate sick organs so patients can keep their own kidney, their own liver, their own heart. Those first two could mean that we would then be able to save donated organs for the truly unpreventable causes of organ failure. And third, another promising technology involves actually growing human organs using cells from the organ recipient themselves. That's growing a new kidney for you from your own cells, which would be compatible with you. You won't require immunosuppression. You won't reject that organ. And finally, I think we need to explore more ways of encouraging people to donate their organs after their death and improve the methods for preserving organs so that more people can be donors and fewer organs end up being wasted, which is a problem that we have right now. We should do all of these things. We can all get behind the effort to save lives. That's a goal everyone shares. But some ways of achieving that goal, I think, are better and less risky, all things considered.
Well, you've given us a lot to think about, Dr. Johnson. Thank you so much for your time.
Thank you very much.
My guest has been Dr. Syd Johnson. She's a professor of bioethics and humanities at Upstate. The Informed Patient is a podcast covering health, science, and medicine, brought to you by Upstate Medical University in Syracuse, New York, and produced by Jim Howe, with sound engineering by Bill Brokel and graphic design by Dan Cameron. Find our archive of previous episodes at upstate.edu/informed. If you enjoyed this episode, please invite a friend to listen. You can also rate and review the Informed Patient podcast on Spotify, Apple Podcasts, YouTube, or wherever you tune in. This is your host, Amber Smith, thanking you for listening.